Hello, everybody, and thank you a lot for coming. I'm Lorenzo Quiroli, and today I'm gonna talk to you about Dagger and also modularization, which can be two connected things. But first, let's start at the beginning, and I'm gonna talk to you about why Dagger. Uh, just to know how many of you in the audience use Dagger as of today, raise your hand. Okay, thank you. How many of you used to use Dagger and have given up on him and tried new stuff? Okay, that's a, a few of them, but not many. That's good. So, why Dagger? I'm gonna start from a simple example and from dependency inversion of control. So let's say we have a class, a very simple one. It doesn't do much so far because it's just a declaration. So of course in this class we might have a use case to fetch some data. And at the same time, in the use case, we might need a repository where we are gonna have the data, and at the same time, again, in the repository, we might have a retrofit instance to do a network request. So if we stop here, we realize already that there is something wrong in here. Not only this code is ugly, but there are a bunch of other issues. For example, we are having a dependency or retrofit directly here in the presenter, and it's going to be hard in the future to change this because the presenter is depending directly on retrofit. It's also not really good because retrofit takes a lot to initialize because it instantiates the OK HTTP client, which is quite expensive to do. And also we might want to share the retrofit instance between different classes. Small break. Can you hear me all right? Good, thank you. So what we should really do is our presenter shouldn't care about how all these classes are initialized. We should just give him a use case in the constructor, and that's all he should care about. And of course, here we have Dagger to the rescue. But what I really care about saying is that Dagger is not the only solution to do this. There are different solutions. You could write your own dependency injection framework. You could use service locator. If your app is rather small and it's just 2-3 activities, probably you don't even need Dagger. You can write some factory, some provider, and that's the Dagger complication is something you don't really need. So don't take it as Dagger is from Google, so I need to use it, because there are a lot of cases where you actually don't need to. Dagger is a good solution for apps at scale. This is a trend in our industry. Apps are starting to grow more and more. We always have to add feature because product manager ask us to do, and the code base is growing bigger, and Dagger is actually something that can help us scale. So in a relatively small app, you can accept some trade-off and some issues, but when things become bigger, those issues become more important, and that's why Dagger is a useful tool to address those. So how can you really decide between yes or no? Like Dagger has advantages. So for example, Dagger generates code, and this is something good because it gives us compile time safety. At the same time, it has a build time impact because generating code is expensive, and in most of the case, it's something not really incremental. We will talk more about that later. The good thing is that it scales with your app, and it has a lot of advanced feature. The bad thing is that the learning curve is not very easy. It might be difficult for a beginner to get in start with Dagger, and also you have a bit of boilerplate, which I'm gonna touch briefly because I don't feel that's particularly the case, but apparently a lot of people are complaining about this. So coming back to the example of before of the presenter, we now have a module which tell Dagger how the presenter need to be instantiated. So it's just a method annotated with a provide notation, and we create a presenter. And this is the kind of boilerplate I was talking about. Like, Dagger should be able to figure out that this presenter need a use case without this module. And it actually can. Like, all you need to do would be using the inject annotation on the constructor, and Dagger will generate a factory, and you won't have to use the provide module. So the provide module is something more to use when you need to give Dagger something that you don't control, like a retrofit instance that, of course, you cannot use constructor injection, so you might need a module with the provide. About this, there are a lot of ways to optimize Dagger, write less boilerplate code, and also optimizing the runtime performances. I'm particularly suggesting 2 blog posts. One is Keeping the Dagger Sharp by PY, and the other one is Dagger 2 on Android by Fred. I won't try to pronounce the surname because my Portuguese isn't this good. Read those are great. They touch slightly different topic from the one I'm gonna touch today. So it's definitely something suggested because it's gonna make easier to use Dagger, and you're gonna end up writing way less code. What I want to talk about mostly today is the build time and module, because I think that's the biggest complaint at the moment with Dagger, especially the build time. So how did it become a problem, though? Because Dagger was released by Square in 2013. Google then took over the project and released Dagger 2 around 2016. And we ended up in 2018, where a lot of people started complaining about build time and everything. So why 2 years later? It was faster before, and it got worse with time. I don't think that's really the case. What really happened is that, especially in 2018, Kotlin started to be adopted a lot more, which is a great thing. Kotlin is a great programming language. It was definitely an upgrade for us Android developer, but it also meant that the annotation processing became slower. KAPT is still not as good as the Java annotation processing, so Dagger ended up getting a lot of bad fame because of that, because the KAPT task is usually the longer one if you profile your build and you're using Dagger. The good news is that we can improve it, and there is something we can do, and there are things that are gonna happen with time. One is that KAPT will support incremental compilation, which is great, and it's something we really need. So finger crossed for that, and hopefully we will be able to try it out soon. The Dagger team is working very hard to make it faster. If you go on the GitHub page of Dagger, in the release page, you can see in the change log of the latest version, there are a lot of optimization about build time and making the annotation processing faster. They started supporting incremental compilation. They started like disabling the automatic formatting, and a lot of other smaller optimization that we should benefit. So if you're using an old version of Dagger, the suggestion is to upgrade because you're gonna get a benefit from it. And the last thing is modularize, because modularization is good, and it's also not the only reason why you should modularize. Like, modularization is going to help you a lot with Dagger and with build time, but it's something you shouldn't do generally just for Dagger. It's a good practice in general. So you're going to get faster build time, either if you use Dagger or if you don't use Dagger. So That's cool. You're definitely going to benefit from it. You're going to get a better separation and encapsulation of your code, which from a software engineering perspective is great. You're also going to get access to dynamic delivery and the new feature that Google is now starting to roll out with App Bundle and, yep, that. Uh, and also something I really want to stress about is that I know it's difficult to make the point to product manager about starting to modularize your app. Product manager tend to see more the short time goal instead of the long time goal. But the fact that we can get faster build time is a huge amount of money saved for our companies, and it's something we should make people aware of and make a strong case for it. The time you say you use today to modularize is time you're gonna save tomorrow whenever you're building something new. So what you can do to get started? Like, modularization can seem really difficult. In reality, it's not difficult, but it's time consuming. I'm gonna say that without any issue. It looks a bit like this every time, because especially when your architecture is a monolithic app module, chances are that most developers didn't really think about dependencies and the relation between them, because everything is in the same module, so I can do this. And you end up having to do that, which is boring and time consuming, and definitely we would like to spend our time better than that, but it's also something good because you definitely cannot use those headphones. So let's talk about feature modules. There are actually two different things you can use today to create new feature module. There is the dynamic feature, which is the new one introduced recently from Google. So the plugin to apply in the build.gradle of the module is going to be com.android.dynamic feature. And you have the normal library, which has been around for a long time. So com.android.library. How are they different, and how should you decide which one you want to use? So there are several differences between them. Dynamic feature, for example, depends on the app. So dynamic feature is going to implement all your app, and it's going to live on top of your application. This means that in your dynamic feature, you're going to have the implement of app, and you're going to be able to reference all the code in your main module, the app module. But at the same time, the app module won't be able to reference any code that is present in the dynamic feature. It also creates a separate APK when you run assemble release, assemble debug. You're going to have two different APK, one for the application and one for this new feature module. If you do a bundle, of course, it allows you to use dynamic delivery. You can choose if you want to deliver this module inside your application, or if you want to request installation at a later stage, and you can also request uninstallation now for it. It's easier to do at the beginning from some point of view, because since you're pulling your class into a module that depend on app, the classes you're going to move, the file you're going to move into this new module are going to be able to reference all the code in the application. So from some point of view, it might be easier than pulling them out. And something really interesting that I found was that the build time impact is going to affect especially when you work on this new module that you have extracted. And this is substantially a bit different from the library module, because when you do a feature with a library, you're going to have the app depending on the library. So the app is going to implement the library. You're going to have only one APK, as we used to do before. You won't have access to dynamic delivery feature. The refactor is going to be a little bit more complicated, because when you pull this class into the library module, then this class won't have access to all the code present in the application module. And something interesting here is that the build time is going to be better when you touch the main monolithic module, because this now has become slightly smaller, while when you touch the new library you've created, actually both will be recompiled. So we are going to see that more in depth soon. One thing that is very important if you take the approach of using library, which is the one that was uh, more popular before, is that the app module should be mostly empty. It should contain the manifest, the build.gradle when you have the signing information, and it should implement, of course, all the features that you have in the libraries, but it's very important that this is empty. Why is it important? Because since the app is going to implement all the features you have in below the app, then when you touch one feature, both the feature and the app module is going to be recompiled. And this is fine if the app module is empty, because that won't take much time. But if you have all the code of the monolithic inside the app, your build time might actually get worse at the beginning. This is a very good approach also when you start a new app, because you don't have a monolithic already, so you're able to do it better at the beginning. And also to do this, you're probably gonna need a core module that sits independent of everything, that is gonna be implemented in all the feature module, because you might have some dependencies that are shared between modules. For example, the retrofit instance, or a database, or something else. So let's see an example to make this clear. I'm gonna. So here we have our app module, and it implements our home module that we have extracted from it. So before it was a big app, now we have extracted a part of it. What's going to happen? Let's say you make a change to the app module now. This is referring, of course, to an incremental build. You make a change to the app module, your app module will be recompiled, but your module is going to stay the same, so Gradle won't need to rebuild that one. And this is cool, you've saved time. But if you do a change to the home module, then both are going to be recompiled, because app is implementing home, so something changed inside home, and app also need to take into consideration those changes. So actually, in this case, you might have a worse build time if you have extracted home, have you lived a bunch of code inside app here. In the reality, though, we said you're probably going to have also a core module, because core is where common dependency sits. Then here, imagine having a whole line of feature that's going to be home, and there's going to be a bunch more. And at the end, there is app who's going to implement all the feature. So here you make a change to home, like before, home and app are going to be recompiled. But if you do make a change to core, then everything is going to be recompiled, of course. And this is where I want to stress the point of app having to be an empty module, because otherwise you start having 3 different layers who are going to need to be recompiled one after the other. And that's actually going to affect your build time in a bad way. And this is with or without Dagger, really. Like, there are some changes in the way annotation processing trigger the recompilation, but in most cases, this is the rule. So, yeah, if the app module is empty, this is totally fine. If it's not, it starts to be more of a problem. The cool thing about modularizing with dynamic feature is not just that. Again, as we said before, you can use the new app bundle feature, you can do dynamic delivery, etc. But your app module can suddenly become your base module. And since the dynamic feature are going to live on top of it, the refactor is going to be easier. And you can see already that you're going to have two layers at the end, because you're going to have your app module and all the dynamic feature on top of it implementing the app module. So let's say now you have home. Home is on top now, and home implements app. Let's say you make a change to home now, and only home is gonna be recompiled. This is especially useful when you're when you're building a new feature, because when you're doing that, chances are that you're gonna recompile a lot to try out changes and everything. And in this case, only the new code will be recompiled. I've been using this for a new feature in my company, and with also Dagger and everything, I was able to get incremental build time of around 15-20 seconds, which was amazing. I've never been happier in my life. If you do make a change to app though, which we assume if you're working on home is gonna happen less, then of course everything is gonna be recompiled. There is no way out of that. So at the end, if you do it properly, both approaches are really good and both leads to a very similar result, which is a great improvement in the build time. It's difficult to get there, especially I know that starting from a monolithic app, getting to the point where app is actually empty and you have everything divided by feature is a long work, but it's definitely worth the final advantage. And like if you do have a monolithic app, something you might also want to do to improve that is to make this app a library and create a new app, empty one, which is going to implement the main app, so that then you can start separating and extracting classes and code from the main app and dividing them into features. So this we talked a bit in general about modules and recompilation, but what about Dagger? I'm going to talk briefly about Dagger Android, which I tried out because when I looked at it, it looked worth trying. But there is a problem with Dagger Android. First, you cannot really use it with dynamic feature for the way dynamic feature work. Second, if you have library modules, something you might be keen to do will be exposing a module with the contributes Android injector inside this module, and then implementing all of those inside a common component in the app. But for build time, while that would work, it would be quite bad for the build time performances, because subcomponents are not really incremental, and every time something changes, their code is generated inside the parent component, so all the Dagger structure will be recompiled because of that. So the general advice about Dagger Android, for my experience, is no, like avoid it. In a dynamic feature, though, we said, how can we really use Dagger? We said we cannot use Dagger Android, and it's better, you can use subcomponent, but not directly with the application component. So the advice will be to use component dependencies, both because that generate a new component outside the main one, which is going to be the only thing that Dagger will have to regenerate when you change the code in the dynamic feature. And of course, generated code cannot be referenced in the base module as all the code inside the dynamic feature. So at the end, you might end up with something like this, which is quite easy. Of course, it can be more complicated. You might have some more module to provide to this application, to this home component, but it's still quite easy. Just have a component dependent of the application one, which is going to provide you the main common dependencies, and then you can inject your home activity here. If you do choose to use library feature, though, you can technically use Dagger Android, like we said before, but it's better not to. You should also avoid subcomponent for the same reason we said before. There are ways of using it, but be careful about how you use it, because again, the code that will be generated for the subcomponent is living in the parent component. And again, I want to really stress this out. The app module should be empty for the better performances in build time. So this looks exactly like the dynamic feature one. So I think this is generally the best approach to go for component dependencies. The code remain quite clean. You don't need any particular hack to make this work. And the good thing is that there is also a separation in the generated code, because the code related to your feature, the Dagger code related to your feature, is going to live inside your feature and not in other module, which is what's going to really make that incremental. So at the end, we see some differences in how we use Dagger between dynamic feature and libraries. There are things that we can do in one and we cannot do in the other, but at the end, we should almost do the same for them and treat them the same, because at least from a build time approach, that might be the best solution to make it work fast and reliably. Something else, tomorrow, 1:40 p.m., Ben Weiss is going to talk about best practices for a modularized app. He's going to touch also the dynamic delivery part. So, well, music. So that's definitely going to be good if you're interested in modularizing your app and taking advantage of this new feature. Personally, I've been super happy with the app bundle. We started using them a couple of months ago, and our APK has been reduced from 24 megabyte to 11, 15. So it's been a great upgrade, and yeah, go for it. Another thing, of course, is that I know it's difficult to relate to a Dagger explanation by voice and by word. So the best way to see it in action might be to take a look to an example. The Plaid project from Nick Butcher and also a bunch of other people are working on it is a great example of how you can structure and use Dagger in a modularized application, taking also advantage of the new feature like app bundle and dynamic delivery. So it's definitely worth cloning it and taking a look at the code to see how everything works together. Finally, we are hiring. I work for Buzu, which is a language learning app. We are based in London. I know there is the whole Brexit thing. Who knows what's going to happen today? But for now, London is not burning yet, so we are very happy of that. We are hiring for all levels, so from junior, mid, senior. You can write to me personally at lorenzo@buzu.com or talk to me in the conference. I'm going to be around for the next couple of days. Or also go look at the website if you might want to look at other positions. I know there might be iOS developer or other engineers. So take a look at it. And that's all I got. Thank you a lot.